My name is Elisa Ledoux, and I'm a lecturer in Mechatronics Engineering at Middle Tennessee State University. This presentation for CompExpo is training engineers to write, teaching project documentation in a senior capstone course. The senior capstone course here is ENGR 4580, Mechatronics System Design. So this is where students work in teams to design, build, test, document a machine that they totally invent themselves. They really love this course. Some of the projects are pictured here. So on the left, there is an automated meat packing machine. On the right, there is a remote controlled hovercraft. They come up with the idea that they want to do, and they get really excited about working on it. And for a lot of people, this is their favorite class. But it's the building and the prototyping that they like, not so much the documentation. So the problem here is that students focus on the prototype and neglect the documentation. So many of them, they are so excited about working on their project that they forget to document along the way. They get to the end and then they rush out the report in a couple days. And so a lot of times the quality is not very good. So that was the problem that I noticed when I first started teaching this course in 2018. So after reflecting on it, my solution that I came up with is use a parallel workflow rather than a serial workflow. So document alongside the prototyping. Their project report format is shown here. So the students get a more detailed checklist, but the basic categories are here. In 2018, that was my first time teaching, the average final report score was 60%. So obviously this is terrible. So I thought, what went wrong? That's when I realized that the students were focusing so much on building their prototype that they didn't document during the semester, and they waited all the way until the end, a couple days before the deadline. So as a result, the report was incomplete and kind of hacked together. So to solve this problem, they need to document along the way. So over the next few years, I implemented parallel workflow in 3 phases. So the original workflow was a serial process. First, they would design their project, then they would build their invention, they would test it to see if it worked, and then they would write a report and finally give a presentation. The new workflow is a parallel process, where the students document alongside their prototype. So while they're designing, building, and testing, they're taking notes all along the way and doing some other activities where they have to produce documentation during class. Then at the end, they will present. So next, I'll go into details on the documentation in the different phases of implementation. The first phase was project management. So here in 2019, I introduced stepping stone assignments throughout the semester to help the students document their design process. The midterm report was the biggest one, this serving as both a checkpoint and a wake-up call. So the midterm, the students have their design mostly completed, and the second half of the semester focuses on the building and testing. So at that point, their final report should basically be about halfway done. Leading up to the midterm, I introduced 4 documentation activities related to the design process. So the first one here is brainstorming. They must consider different ideas for their system, choose the best one. The second one was the system flow diagram. So here's where they map out all the functions of their system and connect them with logic. This helps them to break their system down into subsystems so they can focus on designing each part and assign a different teammate to each part so that everybody can work in parallel rather than in series and make progress faster. For the budget, they estimate project costs by different categories, such as structural materials, actuators, electronics, how much they expect to spend on each one, and then the bill of materials is a shopping list for the prototype. So these are all specific activities that they do during class time, and so they do the activity during class, and they produce a piece of documentation at the end, and because they are building the report along the way, then it's not so much all at the end. So in between the midterm and the final report, they do sprint reports. So this is evidence of progress that they have documented. So while they're building and testing, they may be taking photos of what they've done and writing about it. They will be showing pictures of their CAD designs and explaining how those are changing. They will show calculations. They will show research that they've done, just anything that they're doing on the project, they're forced to document it every 2 weeks. And so this helps them bridge the gap between the midterm report and the final report. So implementing this project management phase did drastic improvement for the final report score. So from 2008 to 2019, it rose 20 points to an average of 80%. So this was great. I was really happy with the results of seeing how when students are documenting alongside their prototyping, and so it's not all rushed at the end, this drastically increases the quality of the reports that they produce. But then I wanted to see, can we get this any higher? Well, they do a great job focusing on their prototype, but they can get very zoned in on their particular project and what they're trying to build, and not necessarily about how that fits in on a global scale. So the point of engineering is to build a better world. So we need to know why we're doing certain things. And so I wanted for the second phase them to focus on the broader impacts of their project. So they can contextualize it on a societal level. What impact does their project make on the world? So I introduced 4 assignments during this phase. The first one here is ecosystem mapping. So this identifies all the entities that affect the product design. So suppliers, manufacturers, customers, regulatory agencies, so that they have an awareness of how their project fits into a broader scheme of things. The market analysis helps them identify a particular customer base for their project and assess whether or not it would be feasible to actually make this into a product that they start selling. Could they make money off it? For the broader design considerations, this focuses on economic impacts, environmental impacts, social impacts, as well as engineering standards and from regulatory agencies. So like OSHA or IEC or ASME or ASTM, anything that is particular to a government regulatory agency, and what kind of laws and regulations would they need to follow if they were for their project design. And then finally, the customer analysis or competitor analysis. This one focuses on analyzing the existing technology, finding out what problems does it have, or what are other people doing to solve these problems that they could perhaps apply to their own design. That way they're not reinventing the wheel, but they're looking at what have people before them done. Implementing these raised the score 2 points to an average of 82. So this is not as significant, but also because these assignments were not line items in the original outline, the students were not losing points previously for not having them. So it did raise the scores a little bit, but also people weren't being taken off points before, so that's why we don't see as much of a change here. The final phase was technical considerations. So some students had these or talked about them in their reports. Some students did not, but they were not explicitly done in class prior to this, so I added 3 additional assignments. The first one here is actuator specification. So this requires students to show their calculations for choosing their motors, their propellers, their cylinders, whatever it is that they need to figure out the exact size. So like how much torque does it need, how much power, or how much force, in order to make sure that will be sufficient for their prototype. For the sensor selection, this is where they need to clearly outline the types, quantities, and purposes of sensors that are needed for their design. And then the AI design worksheet was the most recent one that I added. And this is where they give an AI chatbot their design prompt, ask them for advice on how would you build this project? And then they need to evaluate its response for feasibility and compare it to their original idea to see if there is anything new that they should try or if it is just totally garbage. So that yields some pretty interesting results, but after adding all of these assignments, the score did actually not increase very much. So possibly because these were not specific line items on previous reports, but also because at some point, adding more work does not result in better performance. So at some point, the students are just going to be totally overwhelmed and give up. So because adding these did not increase the score significantly, I don't think anything new should be added. I think that they probably have enough items on the report to provide sufficient documentation without overwhelming them. So let's look at the results in graphical form here. So we can see the first semester, fall of 2018, the 60 average for the report. Then with the addition of the midterm report and the project management phase, the scores jumped about 20 points to an average of roughly 80%. Addition of the broader impacts focus in the second phase raised the scores another 2 points, where they then plateaued. So in conclusion, the introduction of a parallel workflow for documentation and prototyping drastically increased project report scores for the engineering capstone course. Additional assignments added and required plateaued the grade. So this tells us that probably now there is sufficient documentation along the way and that nothing new really needs to be added, because students still do need time for building their prototype. And so we shouldn't turn too much focus onto the documentation. We have now reached a happy medium. All of the assignments that I have talked about are in this open access textbook that I developed with some collaborators at East Tennessee State University. So if you're interested in reading what those assignments are, seeing more details on anything, you can scan that QR code there. And thank you for listening to my presentation.